Why does the second law of thermodynamics forbid perpetual motion machines? Have you ever wondered why some machines seem to defy the laws of physics? One of the most intriguing concepts is the idea of perpetual motion machines. These machines would run forever without any energy input. However, the second law of thermodynamics tells us that this is simply not possible. Let's break it down. The second law states that in any natural process, the total entropy of an isolated system can never decrease. Entropy is a measure of disorder or randomness. This means that energy transformations are never 100% efficient. Some energy is always lost as heat, making it impossible for a machine to operate indefinitely without an external energy source. Now, let's talk about what a perpetual motion machine actually is. There are different types, but the one we are focusing on is known as a perpetual motion machine of the second kind. This type of machine would convert heat energy from a single heat source completely into mechanical work without any other effect, like transferring heat to a cooler area. According to the second law, this is impossible because it would mean decreasing entropy. To understand this better, consider how heat engines work. They need a temperature difference between two reservoirs, a hot source and a cold sink. The second law dictates that some heat must always flow to the cooler area. This means not all heat from the hot source can be turned into work. There is a fundamental limit on efficiency, known as Carnot efficiency, that no real machine can surpass. A perpetual motion machine of the second kind would need to break this limit, which contradicts the second law. Additionally, the second law connects to deeper physical principles, such as the quantum uncertainty principle. This principle prevents perfect predictability and control at microscopic levels. This uncertainty means that some energy dispersal and increase in entropy are unavoidable. In summary, the second law forbids perpetual motion machines because it requires entropy to increase or stay the same. This prevents complete conversion of heat into work without losses. Heat engines need a temperature difference to function, and a perpetual motion machine would violate this by working with only one heat source. The second law sets a limit on efficiency that no real machine can exceed. Therefore, any claim of a machine that produces continuous work without energy input or without increasing entropy contradicts the second law of thermodynamics. This principle helps us understand why energy must be managed carefully and why devices claiming to provide free energy do not exist in reality.